Okay, so this is going to be part 2 of the lesson dealing with the rectangular coordinate system. In part 2, though, we're going to talk about completing ordered pair solutions. Now let's kind of review what we mean by a solution. So in a previous lesson, you had a question similar to this. So the question is this. Is 4, and in this case it would be x equal 4. So is x equal 4 a solution to this equation? Now remember, this is a linear equation, so that's a linear equation in one variable. So all you see is the variable x, so that's why we say in one variable. So a linear equation in one variable. Now remember, a linear equation has this form, ax plus b equal c. So ax plus b equals c. So you have some number times x plus a constant equals another constant. So it has that form. So it's linear. So the question is x equal 4 a solution to this linear equation? So remember what you did in that previous lesson was wherever you saw the variable x, you substituted 4. And so when I substitute the variable x, and I ran out of room, so I'm going to do that here. So when I substitute the variable x, or substitute 4 into the variable x, I get this. I get 4 plus 2, and the question is that equal to 6? And the answer is yes. All right. So x equal 4 is a solution to this linear equation because when I substitute 4 into the variable x, I get 4 plus 2 equals 6. So the left side equals the right side. So this number makes this equation a true statement. Okay, so it makes this equation true. So 4 plus 2 is 6, and 6 equals 6, so that's a true statement. So remember the word true statement. Okay, now here's the other question that you need to ask yourself, or that we dealt with before. So in this particular linear equation, is x equal 4 the only solution? And so if you look at this, what's the only number, or what numbers I should say, what real numbers will make this side equal to 6? Well, the only real number that makes this side equal to 6 is when x is 4. So if x equals 5, or x equals negative 3.2, or x equals 7, this side will never equal 6. The left side will not equal the right side. So x equals 4 is the only solution. So the answer is yes there. Okay, so in this particular linear equation, 4 is the only solution. Okay, now let's go forward with this. So here we're talking about a linear equation. Let me just kind of jump for a little bit. So you see this linear equation. So this is a linear equation in one variable, the variable x. This is a linear equation in two variables. So notice this is a linear equation in two variables. And so a linear equation in two variables has this form, ax plus by equal c. That's the form it has. And so notice that this is that form. So 1 times x plus 1 times y equal some number, some constant. In this case, it's c. Okay, so notice that in a previous lesson when we talked about the word ordered pairs, so when we plotted ordered pairs. So remember, when we plotted ordered pairs, the first coordinate is x, the second coordinate is y. So remember that. So this is x and this is y. That's how we listed ordered pairs. So just like we did here, so is x equal 4 a solution to this linear equation? So wherever I saw the variable x, I substituted 4, and I kind of determined if the left side was equal to the right side or not. You do the same thing here. So where we see the variable x, you're going to substitute 4, and where we see the variable y, you're going to substitute 6. And so basically you're asking yourself this question. So you're asking yourself this. You're saying, all right, so is I'm going to do that here. That's the only space I have. So is 4 plus y is 2, is that equal to 6? And the answer is yes. That's a true statement. So the ordered pair for 2 is a solution. So is this a solution to this linear equation? The answer is yes. because when I substitute 4 for x and 2 for y, that ordered pair makes this a true statement. 4 plus 2 does equal 6. That's a true statement. True statement. All right, what about this one? So here's the question. So is 4 2 the only solution? So remember we asked ourselves this, is x equal 4 the only solution? And we can look at this and say, yes, it is. No other number added to 2 will be equal 6. So ask the same question. So is 4 2 the only solution? All right, well, let's think about that. Let's look at this example. So is 3 3 a solution to this linear equation? So in other words, if I substitute 3 for x and 3 for y, is the left side going to equal the right side? And the answer is yes. 3 plus 3 equals 6. That's your true statement. That's a little check here. So that's your true statement. So 3 3 is a solution. So that is a solution. So going back here, is 4 2 the only solution? The answer is no. It is not the only solution, because we just saw that 3 3 is a solution. What about this? What about 8 negative 2? Is 8 negative 2 a solution? Well, if I substitute 8 for x and negative 2 for y, the question is 8 plus the negative 2 equal to 6? And the answer is yes. So notice that for this linear equation in 2 variables, I'm getting quite a few solutions. So in this one variable, there was only one solution. In a linear equation in 2 variables, I'm getting, it looks like, a lot of solutions. What about 1, 5? Well, if this is x and this is y, is 1 plus 5 equal to 6? And the answer is yes. That's a true statement. Okay, so each of these are solutions. And the same thing for this one is 8 plus 5 plus a negative 2.5 equal to 6? And the answer is yes. That's your true statement. So then the question becomes this. How many solutions do you think this equation has, this linear equation in 2 variables have? And the answer is an infinite number of solutions. It has an infinite number of solutions. So in other words, I could have kept on going. I can find any combination. There's an infinite number of combinations in which when I add x and y, I'm going to get 6. There's an infinite number of solutions. So in the next lesson, after this, in the next lesson, we're going to start graphing these solutions. So you see there's an infinite number of solutions? We're going to graph those solutions. I'm going to see what that represents. When we graph those solutions, you're going to see what the graph looks like in terms of this linear equation. Okay, so now let's continue on. So we know that for the most part, in this course, the linear equation of 2 variables, you're going to have an infinite number of solutions. Okay, so now let's kind of summarize what we just did. So notice this: an ordered pair is a solution of an equation in 2 variables if replacing the variable by the values of the ordered pair results in a true statement. So in other words, when I substitute the value of x and the value of y into the linear equation, the left side equals the right side. So that makes it a true statement. So that would be a solution. Okay, so now let's look at some examples. All right, example 1. Complete each ordered pair so that it is a solution to the given linear equation. So here's the linear equation, x plus 2y equal 8. And here you're told that x is negative 4 and you want to find y. So that's what you want to find. So you're told x is negative 4 and you want to find y. So in other words, where we see the variable x, you're going to substitute negative 4 and you're going to solve for y. That's what you got to do. All right, so let's kind of do this. All right, so we're gonna do this one first. So first, complete negative 4 comma blank. All right, so remember this is x. So I get negative 4 plus 2y equal 8. And now all you got to do is solve this linear equation for the variable y. So to get y by itself, I'm going to have to add 4 to both sides. And so I get 2y equal 8 plus 4 is 12. And to get y by itself, I have to divide both sides by 2. And so I get y equals 6. So the answer is y equals 6. So that goes here. So negative 4, 6 is a solution to this linear equation. And you can check, if you want to check this, we can check it here. So the question is for negative 4, 6 a solution? You do it just like you did this. But you're done. You don't have to go any further. You found the answer. So the order here is negative 4, 6. But if you have time and you can check it, go ahead and check it. So here's what you would do. You would say, again, so wherever you see the variable x, you plug in negative 4. Wherever you see the variable y, you plug in 6. So is negative 4 plus 2 times 6 equal to 8? That's the question. Well, remember, you got to simplify this left side. So you got to use the order of operations. So you got to multiply before you add. So that becomes negative 4 plus 12. And the question is that equal to 8? And the answer is yes. So negative 4, 6 is a solution. Okay, now let's do this one. So this time you're told y is 3 and you got to find x. So you got to find x. So let's go back to the equation just like we did this. So let's do this one. So I get x plus 2 times y is 3, equal 8. So I get x plus 6 equal 8. And all you got to do is just solve for the variable x. I'm going to subtract 6 from both sides. And so I found what x has to be. So x has to be 2. So that goes here. Okay? All right. Again, you can check. If you want to, you can check this. So you'd say, remember this is x and this is y now. So you'd say 2 plus 2 times y is 3. And the question is that equal to 8? Remember, order of operations, you got to add, multiply before you add. So that becomes 2 plus 6. And the question is that equal to 8? And the answer is yes. 2 plus 6 is 8, and 8 equals 8. Okay, part B. All right, so same thing. You're going to complete each of these ordered pairs. So in this case, you're told x is 3, and you got to find y. So let's do this one first. So I'm going to go here. All right, so where we see the variable x, I plug in 3. So I get 3 times 3 minus y equal 12. That's the first thing I did. So the first thing I did was wherever I saw the variable x, I plugged in 3. All right. Now let's kind of simplify this term right here. 3 times 3 is 9, so I get 9 minus y equal 12. Okay, now remember you got to get the variable by itself. So chances are probably what you're going to do is get the variable by itself. So on the left side, you're going to keep it on the left side. That's fine. You would have to subtract 9 from both sides, and you got to be careful if you do that. So be a little bit careful. So 9 subtract 9 is 0. So you're left with negative y, though. Be careful. So that's where you got to be careful. You're not left with y. Your term that's left on this side is a negative y. And then that's equal to 12 minus 9, which is 3. All right. Now remember, you haven't solved for y yet, so don't go here and say y is 3. That's not true. You don't have y by itself. You have the opposite of y that's here. So remember what we did was we wrote this as negative 1y equal 3, and then to get y by itself, right now you're multiplying by negative 1. The opposite is to divide by negative 1. And so negative 1 divided by negative 1 is 1. 1 times y is y. And I get 3 divided by negative 1 is a negative 3. So that's what goes here. Okay? Now, let me just say this. You could have, right here, I'm just going to go ahead and rewrite it. You could have brought the variable to the other side. And so right now you're subtracting y. The opposite is to add y. Oops, that's y. Add y to both sides. And so when I combine like terms, this is 0. So I get 9 equals, now remember this is y, not 4. It looks like a 4. So that's 12 plus y. And then to get y by itself, you subtract 12 from both sides. And notice what happens. 9 subtract 12 is a negative 3. 12 subtract 12 is 0. 0 plus y is y. And you're done. Okay, so you see the difference? You get the same answer. Sometimes, though, when you attempt to do it this way, some students struggle with this. So if you feel that you're struggling, then go ahead and try it a different way. All right. So your solution is 3, -3. Now again, if you have time to check, let's go ahead and check the solution. So where we see the variable x, you're going to plug in 3, and where we see the variable y, you're going to plug in -3. And so, I mean, you're done here, but if you do have time, go ahead and check. So you want to see if this is actually a solution. So you're going to say 3 times 3 minus y. Now be careful here, you're subtracting y. Y is a -3, so put that in parentheses. And then you want to see that's equal to 12. 3 times 3 is 9. Now remember, 9 subtract a -3, remember, means that the same thing as say 9 plus, remember, change the subtraction to addition, you add the opposite, remember, add the opposite. So that becomes 9 plus 3, and is that equal to 12? And the answer is yes, 9 plus 3 does equal 12. Okay, now let's do this one. Okay, so this time you're told y is -2. You're going to solve for x. So you got to solve for x. All right, so I get this. I get 3x minus y. Y is a -2. So notice I'm putting that -2 in parentheses, so I don't mess up, equal to 12. So it becomes 3x. Remember, subtract a -2 means adding a +2. So you really needed to do this. So be careful. You have to remember that subtracting a -2 means adding a, remember, add the opposite, so you're adding a +2. The opposite of a -2 is a +2. And now it becomes an easy equation to solve. So you subtract 2 from both sides. 2 subtract 2 is 0, so I get 3x equal 10. And then to get the variable x by itself, I divide both sides by 3. And so my solution is 10/3. That's your solution, 10/3. So that's x. So this is 10/3. Okay? Now again, you can check. Let's just check this one. You do have a fraction involved. So let's just check it. Okay, so where we see the variable x, I substitute 10/3, and where we see the variable y, I substitute -2. So I get 3 times x, x is 10/3, minus y, and I want to see if that's equal to, I ran out of room, so I want to see if that's equal to 12. That's the question. Well, remember, 3 times 10/3, the 3's divide out, and you're left with 10. And so this becomes 10 minus y, and you want to see if that's equal to, oops, I forgot to put the y in there, excuse me, I'm sorry. I'll go back and redo this. I'm going to do this here. All right, so let's check. All right, so we're going to check this. So I've got to put the variable y. So I get 3 times x, x is 10/3, minus y, y is -2, and you want to see that's equal to 12. Okay, so here we go. All right, now remember, if you're struggling with multiplying fractions, what I would do is rewrite 3 as 3/1, and then say times 10/3. And so remember, that's 3 times 10 is 30. 1 times 3 is 3. So 30 divided by 3 is 10. But remember, though, that what you learned was to reduce first before you multiply. So 3 goes into 3 one time, 3 goes into 3 one time. 1 times 10 is 10. All right, now remember here, you're subtracting a -2. So remember, that means the same thing as adding a +2. All right, so adding a +2. And so the question is that equal to 12? And the answer is yes, 10 plus 2. 10 plus 2 does equal 12. That's a true statement. Okay? All right, so that was part B. All right, so now let's look at C. So in C, all right, in C, okay, so in part C, you have y equals 1/5 x plus 3. So you have this linear equation. And so, again, you're told, in this case, x is 15, and you want to solve for y. You want to find out what this y equals. So where we see the variable x, you're going to substitute 15. So here's what we get. We get this. So I'm going to do this here. So we get y equals 1/5 times 15 plus 3. Okay, so wherever I saw the variable x, I just substitute 15. Now, remember, you got to multiply before you add. So if you're still struggling with multiplying fractions, you may want to rewrite this as 15 over 1. And then it's okay to say 1 times 15 is 15, 5 times 1 is 5, and then 15 divided by 5 is 3. But you really need to remember how to use some skills that you learned in a previous course. So one of the things you learned is to reduce before you multiply. So 5 into 5 is 1, 5 into 15 is 3, and 1 over 1 is 1, times 3 over 1 is 3, 1 times 3 is 3. So I get 3 plus 3, and so that means that y equals 6. All right, so it goes here. All right, now let's do this one. So in this one, this time you're told what y is, so y is negative 4. Okay, so you got to be a little bit careful here. This one's a little bit more challenging, but it's not that difficult. It's fairly easy to deal with. So here's y. You're told what y is, so you can say negative 4 equals 1/5 x plus 3. Okay, so wherever I saw the variable y, I substitute negative 4. All right, now I got to solve for the variable x. So I'm going to subtract 3 from both sides, because right now I'm adding 3. The opposite of adding 3 is to subtract 3. Then I can combine like terms. Negative 4 and a negative 3 is a negative 7, and that's equal to 1/5 x. 1/5 x. All right, now remember in a previous lesson how to solve this linear equation that has a fractional coefficient. So one thing you learned about was you multiply. See how this is 1/5 times x? So where 5 is in the denominator, so the LCD is 5. So we multiply both sides by 5. So I get negative 7 times 5 equals 5 times 1/5 x. So I multiplied both sides by 5. So I multiplied negative 7 by 5, and I multiplied 1/5 x by 5 as well. And then we simplify it. So 7 times a negative 5 is a negative 35. 5 times 1/5, remember, be careful, don't say that's 25, because this is really what you have. 5 into 5 is 1 time, 5 goes into 5 1 time, and so this right here is just the number 1, the coefficient 1. 1 times x is x. So you found out what x is. So x is negative 35. Okay, now let's just go ahead and check this one right here. Let's just check it. All right, let's check it. So I have y equals, well, y is negative 4, so I want to see is negative 4 equal to 1/5 times a negative 35 plus 3. That's a question. All right, so what I would do again is just rewrite negative 35 as negative 35 over 1, and then reduce this product right here, or reduce before I multiply these two factors. So 5 into 5 is 1. 5 into negative 35 is a negative 7. 1 times a negative 7 is a negative 7, and I get plus 3. And the question is that equal to negative 4? And the answer is yes. All right. Letter D. Okay, so again, this time you're told that x is negative 18, and you got to find what y is. So what's going to make this a solution? All right, so I get y equals negative 1/6 times a negative 18 plus 5. Okay, and so I got to multiply these two fractions. So I'm going to rewrite this as negative 18 over 1, and then I'm just going to reduce. 6 into 6 is 1. 6 into negative 18 is a negative 3. And now be careful, this is negative 1 right here. Negative 1 over 1 is negative 1. Negative 3 over 1 is negative 3. A negative times a negative is a positive. So a negative 1 times a negative 3 is a positive 3. And so we get y equals 3 plus 5, which is 8. That's what y equals. So 8 goes here. So that's one of your solutions. All right, so for this one, let's find out what my solution is if y is 7 this time. All right, so I get 7, y is 7, so I get 7 equals negative 1/6 x plus 5. So 7 equals negative 1/6 x plus 5. So I got to get the variable x by itself, so I'm going to do it just like I did this one. So I'm going to subtract 5 from both sides first. So 7 subtract 5 is 2. So I get 2 equals negative 1 6x, because this right here is 0. 5 and negative 5 is 0. All right, and then let's just go ahead and find the LCD here. So the LCD is 6. So I'm going to multiply both sides by 6. And so when I multiply both sides by 6, I get 2 times 6 equals negative 1 6x times 6. That's what I get. So I multiply this side by 6 and this side by 6. Okay? Now, the left side is easy to figure out. The left side here is just 12. 2 times 6 is 12. All right, now be careful with this. So let's see what this is right here. This is what I have. I have 6 over 1 times a negative 1 6. That's what I have. That's what this is. So let's go ahead and multiply these two fractions. So I'm going to reduce first. So 6 and 6 is 1. 6 and 6 is 1. 1 times a negative 1 is a negative 1. That's what that equals. So this becomes right here 12 equals negative 1x, or just negative x. But remember, you got to get the variable x by itself. So don't go here and say that the solution is 12 7, because it's not true. So if you check it, it doesn't work out. So you got to be careful. You got to get x by itself. So right now, multiplying by negative 1, the opposite is to divide by negative 1. So negative 1 divided by negative 1 is 1. 1 times x is x. And that's 12 divided by negative 1 is a negative 12. So that's your solution. That's what x should be. So the solution, so the ordered pair solution is negative 12 7. All right. Now, the other part of, you see right here where you were finding solutions just where it was listed as an ordered pair. Okay, so you're going to learn that you can also find the solutions by using a Ttable. Just the word Ttable. And it kind of does, you're kind of doing the same thing. So you want to complete each table of ordered pairs for each linear equation. So for example, this is what we have. So we have this linear equation, and instead of putting it as an ordered pair, in other words, instead of writing it as 0, blank, we just use the Ttable. But you're finding the same thing. You're trying to find the solutions. So what solutions would make this linear equation a true statement? That's what you're doing. Except this time we're just using a Ttable. So you see, but you can do the same thing. You're going to say, all right, if I'm going to do it right here for this one. So instead of writing it like this, you're going to just fill in the Ttable. Just fill in the Ttable. All right. So notice, though, this is your x. Remember, when doing the Ttable, the first column is x, the second column is y. Okay. Make sure you put it as in the correct order. X, y. Okay. All right. So if x is 0, I get y equals, that you're trying to find, it kind of looks like this. You get y equals negative 7 times 0, and negative 7 times 0 is 0. So here's one of your solutions. That's a solution. Okay? And it kind of makes sense, because if I substitute 0 for x and 0 for y, I get 0 equals 0. That's a true statement. All right, let's do this one. Okay, so for this one, now remember that that's what you have. So this is 0 right here. So this is what you have. You're told x is negative 1, and you're trying to find y. So it looks just like the previous part of this lesson. Example 1 looks just like example 1. Way to complete these ordered pairs. That's what you're doing. You're completing ordered pairs. You're finding what ordered pair would make this a true statement. Okay, so this time you're told that x is negative 1, so I get y equals, where we see the variable x, you plug in negative 1, so I get y equals negative 7 times negative 1. Negative 7 times negative 1. And then remember, a negative times a negative is a positive, so a negative 7 times a negative 1 is a positive 7. So there's your y coordinate. So now you found another solution. So another solution is negative 1 7. All right, now this time, so I'm going to go ahead and circle what we had to find. So we had to find this number, we had to find this number. Okay, so now this time you're told y is 2. So I get this now. I get 2 equals negative 7x. And all you got to do now is solve for x. So to solve for x, right now you're multiplying by negative 7. The opposite is to divide by negative 7. And so I get negative 2 sevenths. Negative 2 sevenths equals And then remember, negative 7 divided by negative 7 is 1. 1 times x is x. So you found your x coordinate. So the x coordinate needs to be negative 2 sevenths. So negative 2 sevenths 2 is a solution. Now again, you can keep on going. So how many solutions do these linear equations in two variables have? An infinite number. They just wanted you to use 3. So you're going to learn in the next lesson that when you graph these linear equations, all you need to graph a linear equation, you're going to see y, but all you need to graph a linear equation is 2 points. But we use 3 as a self-check to make sure it is correct. I didn't make an error anywhere. And so that's why you see 3 here. So notice that for each of these problems we're about to do, there are 3 ordered pairs you got to complete. And so this part is going to transfer to the next lesson. Okay, part B. Okay, so in part B, let's fill in this ordered pair. So you're told x is 0, we got to find out what y is. So I get, remember x is 0, so I get 0 equals negative y plus 2. All right. Now what I'm going to do, see how this is negative y and this is 0? It's more efficient if you just bring y to both sides. So add y to both sides. And so 0 plus y is y, and so I get y equals negative y plus y is 0. 0 plus 2 is 2, and you found y right away. Now, just to remind you, so if you had brought the 2 to the left side, so right now you're adding 2, the opposite is to subtract 2. 0 and a negative 2 is a negative 2 equal negative y. Now you got to remember this is not negative 2, so you got to be careful. So you got to get y by itself. I don't have y by itself, I have negative y. So remember, that means the same thing as negative 1y. So right now I'm multiplying y by negative 1. The opposite is to divide by negative 1. And then negative 1 divided by negative 1 is 1. 1 times y is y. And then negative 2 divided by negative 1 is a positive 2. And that's what you got. Okay? All right, now this time you're told y is 0. So let's kind of do this here. This time you're told y is 0. Okay, so I get x equal. So you're trying to find what x equals. So I get x equal the opposite of 0. Remember, y is 0. Opposite of 0 plus 2. Well, the opposite of 0 is 0, and 0 plus 2 is 2. So there's your x. So 2 goes here. All right. Now, this time you're told x is negative 3, and you got to find y this time. All right, so we get, where we see the variable x, I plug in negative 3. I substitute negative 3. So get negative 3 equals negative y plus 2. So negative 3 equals negative y plus 2. And then you just solve for y. I'm just going to go ahead and bring the variable, I'm just going to subtract 2 from both sides. So I get negative 3 and a negative 2 is a negative 5 equal positive 2 and a negative 2 is 0. And I'm going to write this as negative 1y. Just kind of like I did this. All right, to get y by itself, right now you're multiplying by negative 1. The opposite of multiplying by negative 1 is to divide by negative 1. And so a negative 5 divided by negative 1 is a positive 5, and that equals y, because negative 1 divided by negative 1 is 1. 1 times y is y. So your other solution is negative 3, 5. And you can continue on, but remember, in the next lesson, you're going to see why we chose 3, why we're just doing 3 ordered pairs. Okay, C. Okay, let's look at C. All right, so again, you got to find what y is in this particular case. So where we see the variable x, you're going to substitute 0. So I get y equals 1/2 times 0, and 1/2 times 0 is 0. So that's what y equals. So a solution, remember these are all solutions. So in order for this to be a solution, when x is 0, y has to be 0. All right, so now we want to find, all right, if x is negative 6, what y value will make this a solution? All right, so this time you're told x is negative 6, so this is what we get. We got y equals 1/2 times a negative 6. All right, and so we got to figure out what this is. Negative 1/2, 1/2 times a negative 6. And write is negative 6 of 1 if you have to. All right, and I mean, there are multiple ways of doing this. 1 times a negative 6 is a negative 6. 2 times 1 is 2. Negative 6 divided by 2 is a negative 3. But you have to remember one of the skills you learned, and you got to use it, is to reduce before you multiply. So here I multiplied and then I reduced. Here let's reduce and then multiply. So 2 and a 2 is 1. 2 and a negative 6 is a negative 3. So 1 times a negative 3 is a negative 3. So I found another solution. Remember, these are solutions. Okay, and then now you're told y is 1. And so if y is 1, I get 1, y is 1. So I get 1 equals 1 half x. And then I just got to solve for x. So remember, you're going to use the LCD here. So the LCD is 2. So I'm going to multiply both sides by 2. So 1 times 2 equal, and then remember 1 half x times 2. So 1 times 2 is 2. And remember 2 times a half, well that's just 1. And 1 times x is x. So I found what x is. So x is 2. Alright, so you found your 3 solutions. And then in the next lesson, when you graph those points, when you plot those points, you're going to see what that means in terms of what the graph of this looks like. Okay, letter D. So this time you have x plus 3y equals 6. So you want to find out what y is if x is 0. So what does the solution, in order for this to be a solution when x is 0, what must y be? That's a question. All right, so I receive the variable x, I substitute 0. So I get 0 plus 3y equals 6. And then you just solve for y. Well, 0 plus 3y is 3y equals 6. And then to get the variable y by itself, I divide both sides by 3, because right now I'm multiplying by 3. 3 divided by 3 is 1. 1 times y is y. So y equals 6 divided by 3, which is 2. So 0, 2 is a solution. And you can check it. If you want to check this one, you can. So I'm not going to, notice I haven't been checking all of them. But if you want to check it, you can if you have time. On a test, you're not going to have time to do this. So where we see the variable x, I'm going to substitute 0. Where we see the variable y, I'm going to substitute 2. So the question is 0 plus 3 times 2 equal to 6? That's a question. Well, 3, remember you multiply before you add. 3 times 2 is 6. 6 plus 0 is 6. So that's a true statement. Okay, now this time you're told y is 0 and you want to find out what x is. Okay, so do that here. Okay, so x plus 3 times, remember y is 0, so 3 times 0 equal 6. And you got to solve for x. Well, that one's easy because 3 times 0 is 0. This right here is 0. X plus 0 is x. Right here. And you didn't have to do all these steps. So x equals 6. So 6 goes here. All right, here you're told y is 1, and you got to find x. So let's do that here. So I get x plus 3 times 1 equals 6. Oops, that's a plus right here. X plus 3 plus 1 equals 6. And then 3 times 1 is 3, so I get x plus 3 equals 6. And then you get the variable x by itself. Right now I'm adding 3. I'm going to do the opposite. I'm going to subtract 3 from both sides. And 3 subtract 3 is 0. And then so I get x equal 6 subtract 3 is 3. So 3 goes here. All right, and then finally, letter E. So you want to find what solution this would be if, what solution this would be if x is 0. So you have 2x plus 7y equal 5. So again, where we see the variable x, you're going to substitute 0, and you want to find out what this y equals. So I get 2 times x, x is 0, plus 7y equal 5. Well, 2 times 0 is 0, this is 0, and 0 plus 7y is 7y. So 7y equal 5. And then to get the variable y by itself, right now I'm multiplying by 7. The opposite is to divide by 7. And so 7 divided by 7 is 1. 1 times y is y. And so I get 5 sevenths. And so there's your solution. So your solution, one of your solutions is 0, 5 sevenths. All right, now let's find another solution. Remember, there's an infinite number. You're only dealing with 3 of them here. So this time you want to find out what must x be in order for this to be a solution when y is 0. So where we see the variable y, you're going to substitute 0. Let's do that here. Okay, so I'm going to get 2x. I'm trying to find x, remember. I get 2x plus 7y. Well, y this time is 0, and that's equal to 5. Well, 7 times 0 is 0, and so I get 2x plus 0 equal 5. 2x plus 0 is 2x, and again, you could skip this step. And then you get x by itself. I divide both sides by 2. 2 divided by 2 is 1. 1 times x is x. And so this time you get x needs to be 5 halves. So in order for this to be a solution, when y is 0, x has to be 5 halves. So your solution, so you found two of your solutions so far. 0, 5 sevenths, 5 halves, 0. And now let's do the last one. Okay, so this time you're told y is 1, and you want to find out what x is. So 2x plus 7 times y is 1, equal 5. 7 times 1 is 7, so I get 2x plus 7 equal 5. And now you got to solve for x. So right now I'm adding 7 to both sides. The opposite is to subtract 7. So positive 7 and negative 7 is 0. 2x plus 0 is 2x. Now be careful here. 5 and a negative 7, if you can't remember the rules regarding signed numbers, use your calculator. 5 subtract 7 is a negative 2. All right, and then you got to solve for x. Right now multiplying by 2. The opposite is divide by 2, the coefficient. So 2 divided by 2 is 1. 1 times x is x. And then a negative divided by positive number is a negative. 2 divided by 2 is 1, so this becomes negative 1. Okay? And let's just check this one. Let's just check negative 1, 1. All right, so wherever you see the variable x, you're going to substitute negative 1. Wherever you see the variable y, you're going to substitute 1 into this equation. So this becomes 2 times x is negative 1, plus 7 times y is positive 1, so 2 times x plus 7 times y is 1, equal, and remember that was 5, so equal 5. Order of operations, let's multiply first. 2 times negative 1 is a negative 2, plus 7 times 1 is 7, and the question is that equal to 5? And the answer is yes, so that's a true statement. 5 equals 5. Okay, so that was a long lesson here, but this idea is going to be needed for the next lesson. So in the next lesson, you're going to be graphing these equations. You're going to be graphing these linear equations, and so all of this right here comes into play. Okay? So if you can get a handle on this, then the next lesson will be extremely easy for you. Okay, so that takes care of part 2 of the rectangular coordinate system.